everyone. I really appreciate being here to be able to talk about Vex and our VEXcode Switch, which is kind of our take on the whole block to text challenge that I think a lot of people are facing. Some people, Vex has been around for about 20 years. Some people may have not heard of Vex before, but Vex is, at its heart, a robotics hardware company. So we have 8 different hardware product lines, start all the way down at ages 3 to 4 years old, with kind of constructed robots. And at the younger ages, we really focus on robots that are either very, very simple to build or robots that come pre-built. Then as we get into our middle range, we then have construction-based robots. So we have both plastic-based robots, and then we have metal-based robots for, say, high school and college students. And then recently, we've launched 2 new products, our VEXCTE, which is a workforce development. So you can think of like a large, like FANUC-style robot arm, but one that actually fits on your tabletop and fits within like a foot or 2 of a footprint. And then VEXair, which is our new product that we're launching, pardon the pun, launching this year that will introduce basically a 3rd dimension to our robotics. Now, what's great is a lot of these products like VEX 1, 2, 3, and VEX Go actually came out. We had this great product launch planned for 2020, and then something, with physical hardware products didn't really go over very well. So that's where we launched our VEXcode VR, which is our virtual robotics. So I know some people were in our workshop that we had yesterday, but basically we took the Blockly engine using the Scratch-based fork of it, and connected the Unity 3D video game engine to it to basically make a simulation environment so that students were able to do that with no install required. During the pandemic, you didn't really have the chance to do user accounts or anything like that. So we just made it freely available. It's still freely available today, and I just looked. We just crossed 525 million projects ran on it and had about 12 million hours of coding. So that's something that you can check out that is freely available, just launches right in your browser. So with this, we have a hardware continuum so that we can meet students and educators where they're at, but we also want to be able to meet them at their coding capabilities too. So with some of our younger products, we have touch-based coding that allows you to just do simple sequencing. And then we progress into block-based coding. We have both physical blocks, so basically little magnetic coder blocks that slide into a physical coder so you can do coding away from the screen. But then we also have our Blockly Scratch-based, block-based software. And then eventually we want to get students, as everybody kind of talks about wanting to get into Python coding. A lot of teachers, surprisingly, will think, even in the high school realm, that students with no coding experience should start with Python, just because they think it's more real coding. But of course, that's like trying to teach calculus to kids that have never done math. It's just unnecessarily difficult. So we've always been trying to figure out how exactly do we make block coding more authentic, but then also how do we bridge that transition between block coding and Python coding? Because traditionally, I feel like that transition between the two is kind of like one of my favorite memes here. Where basically people are just like, oh, well, you know how to code in blocks. You can just magically become a coder now in Python. Everything's exactly the same. There's just some more typing. But we know that's not really the case. It can be daunting for students. Students have, some students have a low frustration point. So we really want to figure out how can we kind of meet them at their level of expertise and also their level of comfort. So we started off by building a Python editor directly into our VEXcode software. So the idea here is that if I'm using the block-based environment and I want to go to Python, I don't have to go install a different tool. I don't have to get into tool chains or use the command line or do anything like that. I can turn around and just go ahead and start coding. And then we also took some inspiration from the block-based coding and gave them a toolbox as well. So you have all of your different commands that are available. So you have a reference so that you can get up and basically know exactly what I should be typing into the editor to be able to make the robot drive or do what I'd like it to do. But then we thought, okay, well, how do we then sort of blend our blocks and text together? And that's where we have our Python viewer. So when I do have, behind the scenes in VEXcode, all of the blocks generate Python code. Some of our robots, that Python code runs locally in the browser instance, and then basically in the interpreter in the browser, and then just uses Bluetooth to communicate to the robot. But then on some of the robots, you can actually send the Python code to the robot, and it has a MicroPython instance that runs and actually interprets the Python code live as the robot can then run away from the screen. So this was a way that we were trying to connect the dots between the two environments. But we still kind of challenged ourselves to say there's got to be a better way that we can do this. And one of the things that we always kind of talk about at Vex is the idea of sucking less. That's our challenge, because perfection is really hard. A lot of people try and challenge and try and, they'll spend time and money and resources trying to make something perfect. But ultimately, we really just want to get something out the door as quickly as we possibly can. So our whole goal is, how can we suck a little less today? And we use that as a way of kind of forcing ourselves to not overly perfect something. So we thought about, what was some ideas of here? How could we potentially get and blend these two environments together and make it so that it felt comfortable for the students? And that's where we had the idea of blending blocks and code together. And I distinctly remember when we were coming up with some of these initial drawings for the patent that we filed, going to Jacob, who's one of our developers, who's in the room now, and basically saying, hey, I want to put text in the blocks, and I want to make this work. And he goes, and I'm like, is it possible? And in a very Jacob way, he goes, it is, but it's going to be really hard, so I don't want to do that. And I was like, okay, well, we're going to think about it anyways. And so back in basically 2017 and 2018, we started coming up with the idea of blending blocks and code together in what we called mixed mode at that time. And today, that's now transitioned into our, as you can see, our example here, where we actually have Python code interleaved within the blocks itself. And what's great about this is that we then, in our trying to suck a little less, we thought, well, mixed mode doesn't really explain what it is, so we need a better name for this. So that's where we came up with the name of Switch. So we call these our switch blocks. And the reason where we came up with that name is the idea behind, in linguistics, as learners are learning new spoken languages, they will typically intermix different languages together at the same time. And that has a special term called code switching. So we were like, well, that's kind of what we want to do here in our editor, is be able to blend and allow students to be able to combine and use different features of the software, but also make that choice when they want to make that choice, as opposed to a lot of solutions that make it a wholesale change from blocks to text. So you can see here in this example, I was using a repeat loop, but in a traditional block-based environment, I don't have access to the iterator in the loop. So by converting, I know that that iterator's there. It actually is there and behind the scenes, but I don't really know the name of it or how to reference it. So with this, I was able to then convert a couple of my blocks over, and now I can use that iterator value in order to build a little bit more dynamic capabilities into my code. Now, as we go through this, we've basically converted all the different types of blocks into switch-based versions. And we've also extended so that we have multiple conditional blocks, so you can expand it out for if-else conditions as well. And here's an example of kind of a longer project where then you can independently choose which blocks you convert and when you would want to convert them as well. And if I have multiple blocks, I can loop them together and create a single combination block and a multi-line block at that point. Now, this is really hard. We had originally started with basically just throwing an empty text box into a Blockly block. And then we started doing classroom testing. We realized that it didn't look like code. It looked like text. It didn't really kind of hone into the students, and they were basically, frankly, more confused by it. So that's then when I went back to our Fearless team, and I said, how do we make this better? And so what we basically have done is we've jammed a Monaco text editor into the blocks. So now when I do click into the block, I get a full kind of VS Code style autocomplete system that allows me to be able to also kind of give the context clues and then also do the colorization as well. But then when I click away from the block, I get the challenge that, running a bunch of Monaco instances is very memory heavy, and then we started crashing the browser. So we then had to figure out, when I then leave, I now have to use, I think it's CodeMirror in order to, or a different colorization engine, but basically to leave, to then render the text, but keep it looking the same and keep the colors that are there. And so there's a lot of sort of back and forth that has to happen to be able to make this run on any device. Because one of our other kind of tenets that we have to adhere to is everything has to run on a potato, basically, in schools. We can't really expect them to have a lot of either bandwidth or a lot of computing power. So we're always trying to solve and optimize these solutions as much as we can. Now, with this, we've done a lot of research around this and continue to do research. So we actually worked with Dr. David Weintraub out of the University of Maryland, who's one of the kind of preeminent block-to-text kind of gurus out there. And what's convenient is as we were building this technology, we reached out to him and he's like, oh, hey, by the way, I have a doctoral student, Jimmy. He's looking for a project, so why doesn't he come and he'll just work with you guys. So we basically paid for all of Jimmy's doctoral studies and got him in the classrooms and did testing. So you'll see Lin here, Jimmy Lin, on a lot of these papers. And now he's our director of computer science at VEX. But we continue to basically test this stuff in the classroom. So I have just a few minutes, so I want to fly through because what the most interesting thing about the Switch capability and basically robotics and physical computing is that the students will take it way further than anybody will ever imagine. And so we had a very specific way that we thought Switch would work, which was basically they would just go ahead and like convert blocks. So at any point when I'm in my block environment, I would convert. But what we actually found in our classroom testing is that there were like 8 different permutations of the way that students would test and use the code. So in this scenario, we basically set them up where we gave them a couple of weeks of instruction, and then we asked them to take their projects and use Python, but they got to choose how they used Python. So some students never typed in Python at all. They just converted so that they could say, hey, I did Python, go me. Then other students would turn around and they would basically convert their block, and then at that point they'd be like, okay, I want to change some of the parameters around. So I want to see if I can feel comfortable with this. And it allowed them to choose when they made that transition. One of Dr. Weintraub's research really indicated that students don't ever make that transition once. They want to be able to go back and forth as often as possible at their comfort level. Then we got into convert then reference. Which some of these are really interesting, where they then turned around and they were like, well, I don't know that specific command, but if I convert it, that'll give me the hint of what I want to add to my project, because I have an example basically in line right there. Then type convert then reference. This one probably is my favorite because we watched students do this and we were baffled. So the student got to the point where they were confused on what they needed to type. So they went and converted a block away from the workspace, then used that as the reference to type it into their block that they had dragged in. But it gave them that sense of accomplishment. And that was the biggest thing, is that they felt confident and secure in the coding. They felt like they understood it. They then get into also then just simply modifying the code as well as they went through, clicking into the different blocks. And then also with the autocomplete, some students are terrible at typing. Luckily, autocomplete came and was able to help them correct their errors as they went through. So they were able to use the reference that was there and then get the suggestions that would help them. And then we also had typing with autocomplete. So as we went through all these different permutations, in a group of 25 students, we saw 8 different ways that they were coding. And we had given them this autonomy and this voice and choice to make those selections when they wanted to, rather than just forcing them into a specific medium or a specific way to do so. So this is the last one, where students who felt confident in Python, they were able to just go ahead and type completely on their own. So the last thing is to talk about this is our idea that we've added to our newest product, VEXaim, is this idea of macro blocks. So traditionally, we would build a lot of functionality into the firmware of the robots, that it would then just be a single command that you would send. But we thought, now that we have this switch feature, what if we made very simple commands that would allow you to do complex behaviors, but then when I converted it, it actually unpacked into multiple lines of code. So now students could actually understand, why did this work and how did this work? And then also they could make improvements on it from there. So with that, we've effectively expanded the VEX coding continuum with VEXcode Switch. And I thank everybody for their time. And I don't think we have time for questions, but.